All right, so we're going to start off really simple. Can you both just introduce yourselves and your roles here at SNHU?
I'm Dr. Gary Savard. I'm the Associate Dean for Computer Science.
I'm Tim Hogg. I'm the Technical Program Facilitator of Computer Science.
So today we're talking about computer programming. And just to start off, what educational background is most beneficial to becoming a computer programmer?
Well, computer science is the obvious choice, or a degree in software engineering, or a closely related field. There are some people that don't have degrees in computer science who are very successful as computer programmers because they came up through the ranks.
Yeah, outside of formal education, I would say any industry certifications like AWS certifications or a cert in a specific programming language. Some take the path of taking a boot camp, which is more of like a short-term intensive program to get up to speed very quickly, or just self-study, hands-on projects, things like that could get you working in the field prior to going and pursuing a formal education.
So can you kind of walk us through a typical day for a computer programmer?
Typical. Well, is there ever a typical day as a computer programmer? Probably not. But there are going to be some tasks that you're going to be working on. You're going to be spending time reviewing development documents, in other words, the blueprints that we use to build the systems. You're going to deal with meetings with quality assurance and testing. You're going to do code reviews, which is looking at each other's code, looking for bugs and problems and things like that. And then, of course, you're going to program. And you're going to program based on, usually on industry best practices, company best practices. And sometimes you even have to comply with certain laws and regulations. So there's a lot to it other than just sitting and writing code.
Yeah, and I think it depends on the role, right? I mean, you have some programmers that may just be fixing bugs. You may have some that are building new features in an application. You may have some that are in a managerial role and they oversee a team and they're doing more code review, those types of things. But I mean, for the most part, checking emails, daily team stand-ups, reviewing code and like project updates, writing code, debugging, collaborative sessions with team, planning for the next day and what you're going to be working on the following day, things like that.
So you kind of just covered this a little bit already, but what are some of the common tasks for someone in this position? And if we have to repeat some of what you just said, that's okay.
Some of the common tasks are obviously writing code, sitting down and implementing what a systems architect or a systems engineer or even a team lead has designed for you to build. That's important. You have to spend a lot of time collaborating because often we are not working on something in a vacuum. There may be an entire team working on a single piece of the project. So teamwork is absolutely vital. So you can spend time in meetings, spend time with your peers. Debugging is obviously going to be an important issue. Integration, in other words, integrating the code you've written with the code written by other teams. There's going to be a lot of things that you would do. There could be traceability, verification, and validation, which means you're actually writing what you were supposed to write and you're meeting the requirements of your contract. Some of this stuff is going to be done by higher level programmers. They're going to be software engineers. You may have a verification and validation engineer. So there's a ton of different roles that we could talk about and not just sitting there writing the program.
Gary covered it pretty well. I mean, writing and testing code for applications, fixing bugs or identifying issues in the code, reviewing your teammates' code or your peers' code, writing documentation, super important, whether that's documenting code that you've already written or it's documenting for another engineering team to pick up or build a new feature. And then working with teams to align on project goals. Collaboration is key.
What do you mean when you say bug in a line of code?
An issue, something that's wrong, something that doesn't work as expected.
Yeah, if you've ever
bug.
Yeah, if you've ever had a piece of software you're working with on your computer just collapse, break, go away, that's a bug.
Okay.
We don't get them all. That's a runtime bug.
Do you ever spend like hours looking at code, looking for the bug, and you can't find it?
Yes,
I have spent
days.
I spent more than a week where the whole group of engineers one time, because we had a particular piece of a big system crash and kept crashing. And I sat with a packet analyzer. And if you don't know what that is, we're looking at network traffic, and it's a bunch of ones and zeros and a bunch of other gobbledygook. And after a week of doing that, over a week, I found that it wasn't our software. It was the hardware that was sending the message that was occasionally putting a bit in the wrong place. And this was a multi-million-dollar system, active system.
That's usually
So
how it works.
sometimes, yeah, sometimes that's how it works. Yeah.
Building the big feature is usually the easy part. It's trying to find the one small thing that doesn't really make sense as to why it's not working as expected. That's the one that has you pulling your hair out usually.
Yeah. Yeah. I've heard that before. So I was just curious if you had experience with that as well.
And then you'll see team members put their status as squashing bugs. Usually that means they're going to disappear for a day or two.
Yep.
Yeah. I've had the experience where, something has gone to support like this system had, but it was beyond the support personnel, support engineers, the debuggers that fix production software to handle. And I was in development. So I was put on an airplane and went out to a customer site and sat there looking at packets traces for over a week.
Is that fun? Do you enjoy doing that?
Finding that I'm very determined. In ways I say yes, because I'm going to find it no matter what. And that's the kind of the mentality you have to have. But do I like looking at ones and zeros and other gobbledygook for hours on end? Probably, not my favorite thing to do.
Yeah. But that feeling when you
important.
find it,
Yeah.
that feeling when you find it must be great.
Yeah.
What programming languages and software are most useful?
Well, now Java, Python. Python's very big. JavaScript, C++. For example, I have used many languages, and I still do. But I'm primarily a C++ programmer, which is very useful if you're going to be writing embedded software, the devices, mobile phones, if you're really doing low level stuff, robotics, automation, that type of thing. But C# is a great language. It's used a lot for Windows products and develop Windows applications. It really depends on what you're doing.
Yeah, I would say all languages are useful depending on the need, right? Because some languages are more appropriate for a given application or system than others. But as far as most common or most popular, Python, Java, JavaScript, C++, right? But again, depending on what the intended purpose is. Software, that depends. I mean, you've got your integrated development environments, your IDEs, VS Code, Visual Studio, JetBrains, IntelliJ, NetBeans, Eclipse. Again, depending on the language of choice and the project, that could vary as well. And then you have your version control systems like Git or GitHub, and then project management tools, Jira probably being the most common.
So, what are some good ways to keep your industry knowledge and technical skills up to date?
Practice and playing and having curiosity. This is a field where you have to like to learn. You have to have a curious type of personality, not in a negative way, but in, I want to figure this out. Oh, this is a new tool. This is a new language. I'm going to play with this. Okay. And usually, software engineers tend to, work in multiple companies over their career, and those companies are going to be using different technologies. So you're going to have plenty of opportunity to work with different technologies, and you really have to have that drive to say, hey, well, there's this new programming language called Rust. I'm going to use that. So let's figure that out. And you just sit there and you play. You make a game. You just play with stuff.
I like that. Yeah, practice, side projects. You have to want to be a lifelong learner because this field is rapidly evolving. New languages, new frameworks, updates to languages, updates to those frameworks is constant. So making sure that you stay up to date, whether that's following tech blogs or industry news, forums, joining networking groups, going to conferences, taking online courses, going for certifications. And then I would say finding a mentor too is really a good way. Somebody that's more of a senior developer, or manager or whatever the case may be that can mentor you and guide you.
So how should a computer programmer approach learning new coding languages and software?
Well, the way I do it is I look at documentation. I may look at the associated websites, the blogs, I may grab a book or even go through a course. I'm not necessarily looking for a certification. I just want to get a head start in it. And then I just sit down and start doing it. I don't think there's you can't read a book and know how to program because it doesn't transfer. I could memorize a book and I still can't write code. It's really, I think of it as kind of beating my head against the wall because I'm always going to make a lot of mistakes when I first start because I really don't know what I'm doing. I'm kind of fumbling. But that's the best way to learn how to program and learn a new language.
A lot of the foundational knowledge, like if you're proficient in an object-oriented programming language, let's say Java or Python, right? Moving to another language isn't that difficult, right? The syntax, the code structure is different, and you could read official documentation or maybe start small, start with some basic tutorials and things like that to understand the differences. But foundationally, it's the same, right? But yeah, practice, hands-on projects, applying something to a real world problem. And that's really the best way to learn something new for sure.
Yeah. Join an open source project. In fact, I just gave a student that recommendation a master's student who contacted me, says, what do I do? So, well, here's a list of some open source projects and volunteer to write some code for them.
So how do you know, and again, this is a very basic question, someone who's not too familiar with coding, how do you know which language to use for which situation? Like what do you use Python for? What do you use Java for?
Good question. It's going to depend on, and it's going to come with experience. It's like, for example, I mentioned C++, a lot of embedded programming, a lot of low-level stuff where you're talking directly to the hardware. A lot of really, if you need a lot of speed, C++ is a very good language for that. Now, if I just need to crunch tons of data, I'm going to use Python because really that's what it's designed for. It's got all kinds of these built-in libraries that allow you to crunch data and do math without having to write a lot of code. And so there's trade-offs. C++ is very complicated. The syntax is very, very dense. It's, a little harder to write code with it, but it's very powerful in other ways. Python, you can write a couple lines of code and do what would take you, 500 lines in C++. So it really depends on what you're doing.
Knowledge, experience.
Yeah.
Knowing, reading, and understanding what language is used most commonly for certain tasks and what it excels at, right? Like Gary said, what available libraries are there, which is basically like third-party code that's written that you could use to simplify your application and what you're trying to do. And then it's like JavaScript is the programming language of the web, right? If you want to develop a website, an interactive website, you have to know JavaScript, right? So it just depends on the language and what the intended purpose is of the application. Some can do it all. Java could be a backend for a website. Python could be a backend for a website. But it's understanding which one is the most efficient. And again, like what libraries and frameworks exist for that language.
Right. And you're going to, and I've actually had quite a few students ask me, well, why don't you teach Kotlin? Why don't you teach Rust? And so they hear these buzzwords and they maybe watch YouTube and hear, well, Rust is going to be the C++ and C killer and Kotlin's going to kill this and it's going to replace this language. I've been hearing this my whole career. It hasn't yet. No. So there are always going to be new languages and new technology popping up. The ones that have the traction are the ones that are going to prevail. There are languages like Visual Basic, which took off and then kind of disappeared. It's not used for much anymore because it didn't quite do what we needed it to do. C# took its place. So there are a lot of things like that. You hear buzzwords and, I got to go learn this language to learn that language. No, what you need to do is you need to ask someone, what if I want to work at Microsoft, and I want to work in AI, what technologies do I need? And then, I focus on those. If you try to learn everything, you're never going to. In all the decades I've been in this career field, I still know nothing. I say I know nothing.
So my next question, actually, you've kind of demonstrated throughout this entire interview is, do you have any advice for communicating complicated technical info to non-technical stakeholders?
It's critical. You need to learn from someone who knows how to do it. You're going to have a business analyst, a systems analyst who's usually going to be very good at that. You need to learn how to be non-technical and explain things in a simple way. There are, yep, right, right. And if you're working in a small company, you may be the analyst that's going out and doing the programming. I've done that many times. And so I can't go out and talk about, do you want me to create a relational database sitting on top of this? No. What do you need? I need to store information. I need it presented in this way, and that you have to speak at that level to them. And there are actually books that talk about it.
Put it in a way that the audience understands, right? I mean, don't explain the logic behind this function and how it operates and why you wrote the code the way you did. That's just going to be, they're gone. It's going over their head, right? But you can explain something similar and tie it back to a business outcome that they do, right? I wrote this function because it's going to produce XYZ for you. And they say, oh, okay, well, that makes sense, right?
You can write business cases as well and use cases. So you may have these little stick people, and the stick person is working on a screen that does A, B, C, and D.
Use visualizations, flowcharts, diagrams.
Yes. Yeah, definitely.
And don't use acronyms, I've learned. Like something that you may use every day with each other will not make sense to somebody else.
Right.
So what advice do you have for someone considering pursuing a career in computer programming?
Well, you've got to want to do it. First off, you've really got to want to do it because, it takes a lot of effort. You can't learn the program overnight. You're going to have a lot of pitfalls. When you first start, it's vertical learning curve. It's really vertical learning curve. So you have to want to learn for your entire life.
Yeah. Stay curious, stay committed.
Yeah. You have to be. And
don't beat yourself up because you're going to make mistakes. It's going to get hard. Like Gary said, I've worked in this industry for a long time, and every day there's a challenge. Right. And I run up against something that I haven't run into, and you got to figure it out. That's never going to stop in this field. So as you're learning, give yourself some grace. Know that through time and practice, you're going to be able to work through problems. You're going to be able to solve them, and it's going to get easier for you to do that.
It will. You need to get away. You don't want to sit there for hours trying to fix a bug. I fix my bugs in the middle of the night while I'm sleeping. Or I'm out riding my motorcycle and, that was the problem. Beating yourself up and just, it's great to be persistent, but there's a diminishing returns if you just sit at a computer all day.
What are some common misconceptions about this role?
Yeah, one that you're not solo. I know there's this misconception of like the programmer in their basement or in a dark room with the matrix on the screen. That may be some of the times, right? If you're really like zoned in and working on a specific task and knocking it out. But, software development, application development is very collaborative. You work with teams, you communicate with team members all day long. I'm probably in Teams or Slack more than I'm even in my IDE writing code, right? So communication is key. And then I would say another one is there's a misconception that it's extremely math heavy, or you have to be a math genius to be a developer or programmer. In some instances, yes, right? I mean, if you're an AI or machine learning engineer that's writing the next alternative to GPT, probably need to know some linear algebra and math. Or if you're writing an automated, robotics surgery system, right? Like you're going to have to know math. But web development, mobile application development, it depends on the role, but that's more about application logic, right? And there's not a whole lot of math involved in that. So I think that's a misconception too. You can get into this industry without being a math genius, although it is helpful. And in most computer science programs, we do teach math. And that's really just to set people up to be very versatile in the field, but not necessarily a requirement depending on what your role is.
And that one thing I'll add to that is, a lot of folks have the misconception, like Tim said, you're sitting in a basement in a dark room and writing code all day. That's not the case. And one of the things that's really great about this career field is if you move around a little bit, or if you work, I owned a software business and had employees and all of that. our projects changed all the time. So Tim talked about medical robotics. I worked in the medical software field. I had to learn a little bit about medicine. I've done human resources software. I had to learn about human resources. You can't code if you don't understand it at some level. So that's one of the things that is great about this career field is I get to do things and be places that a lot of people who are in just a typical 9-to-5 job didn't get to do. I used to do a lot of stuff for the DoD, and I can't talk about it, but I've also worked for manufacturers, and I've been in their facilities and learned how their facilities work and how their business processes work. So it can be very interesting that way, because what it's doing is it's giving you a broader base understanding of business and how businesses work, because ultimately that's what we're doing in a lot of cases as a programmer, is coming up with better ways for a business to work.
What do you enjoy most about being a computer programmer?
Well, I would say, I don't consider not quite a computer programmer, because there's more to it than that. I'm a software engineer, certified software engineer, software architect. So there's a lot of different things. I've been a database administrator. I have designed all kinds of different things. So there's more to it than just programming, and that's what I really like. There are many, many different roles. I've been a CEO. My company wasn't that big. I had 50 employees and about 100 contractors, but that still made me a CEO. So I learned the business side of things as well. So for me, it's just, you can go anywhere with this. It's not just sitting writing logic all day long. There's a whole lot more to it.
For me, I love solving complex problems with code, innovating, creating. I mean, it's an art, right? And software development is an art for sure. You're a creator. So I love that. I love the collaboration, working with diverse teams, getting different perspectives and insight into a problem that you're trying to solve collectively as a group. And just the fact that it's ever evolving. Like I said, you have to be a lifelong learner, and you have to have that drive to continuously learn, which I love. I love taking courses, and I'm part of all these forums and groups, and I get all these updates daily, especially with the AI boom right now. Things are changing every day, and so it's really interesting to see that, and then to go and try to learn that new thing. So I love that that part of it.
And just seeing the evolution of technology, I think. I've been a little bit older than Tim, and I worked in AI when it was very, very painful and very, very limited, and we couldn't do a whole lot, but we were still working on it. And now it's just like mind blowing. It wasn't that long ago that I can recall spending a lot of hours trying to do basic things and writing code to do basic things. And now we can go to ChatGPT and it spits it out in a millisecond.
Well, that was it for all my questions. Thank you both for joining us.